Okay, this next problem is about finding a box plot for the percentage of federal prison populations, the increase in the percentage in 20 northeastern and midwestern states in 1999. So I am going to take that data and copy and paste it into Statlet. If you need to, you can pause and type it in. But since I have the actual Word document, I can just copy and paste it. I'm going to use one quantitative variable, single group. Prison population growth is what I would call this one. And I'm going to make a histogram first because you always want a histogram of your data. Let's look at this histogram and see what it looks like right there. That looks kind of symmetrical and normal, right? So I'm going to take that and paste it in. Oops. Copy that. Let's paste it over here. Because it's always good to have the histogram for data, to take a look at it and see what it looks like. All right. And the next thing I'm going to do is a box plot. This is the first time we've done the box plot on this. So let's go ahead and do a box plot. So I'm going to change from histogram to box plot. And I'm going to bring with me on this box plot, when I copy it over, the new, and I'm going to bring all of that. Okay, so I'm going to take that and copy the box plot over. And I like to bring the number summary too of all the Q1, Q3, min, max, all that. All right. So let me make this graph a little bigger so we can mess around with it a little bit. All right, now that I have brought the box plot graph over that we calculated using Statlet, I'm going to show you how to make it by hand, just to show you how a box plot works and how it's actually constructed. So the first thing they do, and they have the construction steps up here, you draw a single axis spanning the range like that. I just copy and pasted that. So draw short lines at Q1, Q2, and Q3. Remember, Q2 is the median, right? That's Q2 right there. So at Q1, like 4.45, there would be short line. Q2 at 5.4, there would be a short line. And Q3 at 6.35, there would be a short line. And those will make a box. You'll draw a box around them. Q1, oh, let's label that a little better. Q1, the median, and Q3. You pretty much never call that Q2. People always call the second quarter, which is the halfway point, the median. I mean, you can leave it Q2 if you want to. So that is 5.4. Q1 is at 4.45. And Q3 is at 6.35. And so that's how you draw those. And then you need your fences. And fences are anything outside of the fences is considered an outlier. It's how you actually calculate an outlier. You've always thought of an outlier as just data that's way away from all the normal points. There's actual definition for it and a formula for it. And it's these two fences right here. Lower fence, Q1 minus 1.5 IQR. Upper fence, Q3 plus 1.5 times the IQR. So let's calculate the fences. The lower fence is Q1 minus 1.5 times the IQR. And remember, IQR equals Q3 minus Q1. So what is this going to be? Q1 is 4.45 minus 1.5 times the IQR, which would be 6.35 minus Q1, 4.45. And so calculate that using a calculator. So I'm going to pull up a calculator here. And so what do I have? 4.45 minus 1.5 times the IQR, which is 6.35 minus 4.45. Enter, and you get 1.6. 1.6. So the lower fence is 1.6. Anything below 1.6 would be an outlier to the left, lower than that. The upper fence, we have its equation right here, Q3 plus 1.5 IQR. So that would be Q3 is 6.35 plus 1.5 times, and we already got that, 6.35 minus 4.45. And so I'm going to find the upper fence. So it is 6.35 plus 1.5 times 6.35 minus 4.45, and it's 9.2. So 9.2 is the upper bound of the fence. 9.2. And what that means is, if you have any numbers below 1.6, they're an outlier, and they need to be a dot on your graph. If you have any numbers above 9.2, they would be an outlier. So let's look. Do we have any? We do, and it's at 1.3. That's below 1.6, right? So that would be an outlier out here. 1.3. So just draw a dot at 1.3, and that's an outlier. 1.3 is the outlier. And let's check on the right and see if we had anything bigger than 9.2. That would be an outlier to the right. I do not see one. There is not one. And look at the box plot that we got from Matstaplet. It doesn't have one, right? So there isn't one. The Staplet will show it as a dot automatically. You don't even have to calculate this. Now our fences, like these whiskers that we draw next, is you draw a line from the box out to the inside data value that is closest to each of the fences. So what is the lowest data value that is not an outlier? What's the next lowest after 1.3? I see 3.2. So that would be the lowest. 3.2 is where you would draw your whisker, like that. And what is the highest one? It is 8.0. And see, that's where it is on there too. I would draw a whisker. And that would be the highest piece of data that I have. So what this is telling you, this graph, is like any outliers you have are going to be dots. And it's always good to know your outliers. You'll be asked that on the test too. What are the outliers? Anything within the fences, the lowest number within the fence will start the whisker. And then you'll go up here and it's Q1, starts the box. The median is the middle of the box with a line. Q3 is the end of the box. And then the final whisker out here is the biggest number that you have that's in the fences. And then if there's any outliers out here, there'll be a dot. So that is how you construct a box plot.